Welcome to the next experiment of power system simulation lab. So in this experiment, we will be using the Transient Security Analysis tool of DSA tool software. We will be creating contingencies and learning how to analyze using DSA output analysis module. So a brief introduction about software is mentioned in the manual and the detailed steps for the activity is mentioned. So we can directly proceed to the tsert. Click on tsert. The window will open like this. Click on file, click on new. So to create a new tsert case, it's already checked. Click at new tsert case, click on next. So as we will be using the we will be performing tsert for the SMIB case that we have already done the power flow. So we have to mention one power flow data file. So click on browse, select the SMIB power flow data .pfb file, click on the solve base power flow before simulation, click on next. So dynamic data file also need to be specified. So in this, click on create, click on models. For generator 1, so there are different models available. So for generator 1, we will be using DG0S2. Right click on the blank space, create new model, search for the bus on which generator is connected, click on bus 1 and click OK. Fill in the data as given in the manual. The MVR rating is 2220, RA is 0.0030, XT is 1.81, XQ is 1.76, XL is 0.15, XD is 0.3, 0.65, dash is 0.23, is 0.25. So remaining values we can fill according to the manual. So ensure that click the model as set the model as in. So after filling in the data, click on OK. So for generator at bus 3, use the model as Cgen. Right click on the blank space, right click and click on create new model. Search for the bus generator at bus 3. So MVR rating is 2220, RA is 0, XT is 0.5. So set the model as in. Click on OK. So here we will be mentioning only these two parameters. For the upcoming experiments, we will be using the other exciters, PSS, governors, etc. So for time being, we will save this file. Click on save and save the file as some maybe. So after saving the file, this file path to the file will be mentioned here. So click on next. So monitor data. This is also a mandatory data that is to be mentioned. So this has to be created. Click on create. So in this file, you have to mention which are the components that are to be monitored. So if you click on generator, you can monitor either individual generator or generator by area, zone, vicinity, or entire system. So if you are selecting individual generator, you have to click on add and select the individual generator and add individually. So here we will be using this generator by system, the entire system. Click on add, click on system. So the entire generators available in the system will be monitored from 0 MBA. So it will be monitored. All generators having rating greater than 0 MBA will be monitored. So if you want to set any additional quantities that is to be monitored, you can check the boxes and click on OK. So here we will be using the bus. We will be applying same monitoring from bus 0 kV to 999 kV. What all buses are available will be monitored. Here in the SMIV system, there was only buses up to 230 kV. So by default, it will be using only up to that much kV bus. It will be monitoring only that much available buses. Click on OK. In the branch also you can select. So any additional quantities if required, you can check and click on OK. So click OK and save the monitor file. Click on next. So this is also a mandatory data, that is a contingency file. So to create a contingency, click on create. So initially we will not be creating a contingency. Click on create a no fault contingency. Click OK. So the contingency name is no fault contingency. Click OK and save the file name. So click on next. So the rest of the windows are optional, so you can skip. Click on next. So finally we can mention the title of the TSAT case. I am keeping it as default base scenario. Click on next. So the TSAT scenario is created and you can save the file. So after creating the TSAT case, a window will open up like this. So you can run the simulation by clicking on run. So there are different analysis possible: base case analysis, transaction analysis, run back analysis, etc. Here we will be using base case analysis. Click on base case analysis. So the base case analysis is being run. So click on result summary. You can see the transition stability index is 62.24. The status of system is secure. The contingency description is no fault contingency. So if you want to see the detailed result, click on view and click on result, or the result is available here. So after clicking on result, the DSA output analysis module will pop up. Here you can see the case, the SMIB case which is being created, the scenario, it's base scenario, contingency. Here we have no fault contingency, the quantity to be monitored, and click on plot. So the quantity is already plotted. So you can see the generator terminal voltages as of bus 1. You can see, if you want to zoom, you can click on the zoom in button and you can zoom. If you want to zoom out, and you can click on this. So whatever plot you will be, whatever the curve legend you will be clicking, that plot will be highlighted here. If you want to see only the plot for bus 3, that is this plot, you can right click on bus 3, that plot, and set selected quantities. So only that plot will be shown. You can always come back and select all quantities. If you want to see rotor generator angle in degrees, you can plot. The angles will be shown here. So next, for the next task, we will be creating a contingency. So we close this. So in order to modify the case, double click on this base scenario or this part, double click here, and you will get, you can modify every component. You can say, if you are creating a contingency, click on contingency data. You can see already one contingency file is mentioned that is a no fault contingency. Either you can edit this or you can create a new file. So here I will be creating a new file. Click on create customized contingency using the contingency editor. Click on OK. So the contingency is, let's say, a fault on line 1. So simulation length is given as, say, 50 seconds. Click on add fault, before fault simulation at time, say at 5 seconds. A fault is being created, say a single phase to ground fault on line. Select the line connecting bus number 2 and bus number 3. There are 2 lines, so I'll be selecting one of the lines. Click on OK. Distance of fault location from the bus, say the distance is 50%. Also we are clearing, if you have to clear the fault, let's say at simulation at time 5.2 seconds, you can clear the single phase to ground fault. So we can click on OK. We can save the fault case. So SMIB fault contingency is being loaded here. Click on OK. So again run the base case analysis, and the result you can see in the result summary. You can see the fault on line 1 contingency with the transient stability index 56.96. The status is secure. So if the system is not secure, it will be showing us the status will be insecure. So to view the result, you can either go to the view result, or the shortcut is already mentioned here. So DSA output analysis, DSA tools output analysis module will be showing. Click on the contingency, fault on line 1. Say you have to view the general triangle in degrees plot, so you can see the general triangle. So it is always better to plot the angle with respect to the relative angle. So here this plot is with respect to generator at bus 2, at bus 3. So this angle at bus 1, this plot is with respect to the generator at bus 3. So whatever plot you select will be highlighted. Suppose you need to see the maximum value of this curve. Either you can zoom in and find out the maximum value, or directly go to tools, go to curve statistics. You can see the maximum value of the curve is 98.72 degrees. That is the maximum value. The time at which the maximum value occurs is also mentioned. Similarly, for the minimum value is also given. So the curve statistics can be seen. And if you want to see only this curve, you can right click and see the selected quantities only. If you want to give some other colors also, you can set the curve colors. That is also possible. If you want to export the data, click on data. You can export this data to Excel file, or you can view view data in data itself. There is a view. The data will be shown here. You can edit and copy table to clipboard and copy it to an Excel file and plot it from there. That is also possible. The graph also you can plot, copy it to clipboard the plot only, or you can set the curve colors, etc. So that's all about this part. You can close, and we can see how this transient stability index is calculated. This is already mentioned in the manual. So if you need more information, you can always go to help and open user manual. So more discussions about stability indexes are already mentioned there. So here, apart from this, we can do uh, critical clearing time calculation, etc. That will be uh, discussed in the upcoming experiments. You can set it to critical CCT calculation, etc. Here we will be using only the stability margin, and we used this angle margin algorithm, and that is why we are getting this transient stability index. Okay, that is all for this activity. Thank you.